During their service life, machine tools must be calibrated regularly in order to meet the accuracy requirements of modern manufacturing. For this purpose, trained personnel of the machine manufacturer must travel to the installation site of the machine several times a year, depending on the machine type and area of application, and carry out the corresponding work. Such procedures are associated with enormous personnel, time, and monetary expenditure. Moreover, not least the current COVID-19 pandemic and the associated global effects show how vulnerable such dependencies can be. The reason that no machine recalibration has been carried out digitally so far is due to IT security concerns, the necessary verifiability towards third parties, and the complexity of the calibration runs. The consortium, consisting of Metrom, 5PM, Software AG, the Dresden University of Technology, and the Fraunhofer IWU, as well as the partners SciTech and the Vienna University of Technology, has developed a solution for this problem with the Audio project in order to move machine recalibration comprehensively into the digital space. The project was funded by the Federal Ministry for Economic Affairs and Climate Action. On the one hand, the designed architecture reflects the specific use case of remote machine recalibration. On the other hand, it remains generic enough to be the basis for other data-driven services. Examples of this are temperature curve evaluation, condition monitoring, and predictive maintenance. The two parties, the machine operator, that is the customer, and the machine manufacturer, meaning the service provider, communicate via the audio platform. This audio platform, created in the project, takes over the pre-contract processing. This includes the selection of the type of service via the integrated marketplace, pricing model, and data exchange, or the provision of API keys for automated execution. The special feature here is that a fingerprint of all audit-relevant communication is stored in the YOTA tangle and thus secured against subsequent manipulation. The YOTA tangle is a directed acyclic graph and basically a distributed ledger technology similar to the well-known blockchain technology such as Bitcoin. However, transactions in YOTA are not stored in a linear chain, but in a tree-like construct, the so-called tangle. In the project, both the automated variant, for example via REST calls, and the manual variant, the exchange of data via up and download on the platform, were implemented. This leaves the service provider free to choose how to offer their data-driven services. For the service call, the customer needs a data source and a corresponding gateway, or a computer with an internet browser. In the use case of machine recalibration, this results in a machine tool with machine control, the double ball bar measuring system, and the gateway. In the automated case, the machine operator performs a predefined measurement run, whereupon the measurement data is collected by the gateway and sent via the platform to the server of the service provider. There, specific algorithms calculate the access value correction parameters based on the measurement data and the actual target position deviation hidden in it. These parameters are returned via the platform to the gateway and thus to the machine control system. In the manual case, the measurement or correction data must be manually uploaded from the machine control to the platform and downloaded again by the machine operator. Through this procedure, the securing of hash values, meaning digital fingerprints of the exchange data, the machine recalibration is successfully moved into the digital space in a forgery-proof and auditable manner. Recalibration, however, has also been transformed, improved and simplified. The use of the double ball bar system replaces the time-consuming single-point measurements. With the single point measurement, individual poses are approached by means of measuring probes in 5 directions and an axis value correction is calculated. The double ball bar enables the recording of measured values during path movement, taking into account all spatial axes and the possibility of approaching extreme poses one after the other. The core of a double ball bar consists of a high-precision linear measuring system with a magnetic ball at each end. These balls are guided in floating bearings on the spindle and machine table. As part of the audio project, a wireless variant of the double ball bar was developed and implemented, which enables it to be handled more freely. This further development of the double ball bar was advanced at the Chair of Machine Tool Development and Adaptive Controls at Dresden University of Technology. The most important thing we have is the double ball bar, which is variable in length with the integrated transmission technology in Bluetooth Low Energy. Next is the centering fixture for the machine table. This includes the counterpart, the centering fixture for the main spindle, and so that both can be aligned with each other, the alignment ball. To prepare the system for measurement, you first have to switch it on and then carry out a calibration. For this, the Renishaw calibration standard is used. You place the ball bar here in the corresponding receptacles and press the Calibrate button in the software. This simplification and use of the double ball bar compared to the single point measurement allows a machine operator to perform the measurement himself without additional training, using reduced instructions. In order to be able to transmit these instructions to the machine operator as comfortably and reliably as possible, an assistance system was developed in augmented reality. This guides the operator through every single step of the service process, from setting up the double ball bar to sending the data to the service provider. It recognizes individual components and establishes a real-time data link to the OPC UA server of the machine control. The assistance system was implemented for AR glasses, tablet, and PC. In the AR assistance system, the information is directly linked to the near environment. It is therefore practically an extension of reality. Thanks to the AR system, the user knows exactly which steps and handles he has to perform on the machine. If the machine operator has followed all instructions correctly, the measuring run can now be started. The following section shows circular and orbital runs. Finally, let's take a brief look at how to work with the marketplace for services and the booking process. Basically, there are 2 roles for the platform participants: service provider and customer. After a short registration with one of the 2 roles, one can log into the platform and get started. Let's first look at the platform in the role of the service provider. Before a service can be released on the marketplace for booking, a corresponding API must be deposited on the platform. For this purpose, the platform provides an upload manager that simplifies the upload. In addition, a description of the API as well as an image and the assignment to a category are directly deposited here. The service must be hosted by the service provider. The platform itself only handles communication and does not provide any services directly. There is an overview of all APIs uploaded by the service provider available. In this view, an API can be activated or deactivated, published on the marketplace, and assigned to a pricing model. Editing or deleting an API can also be done here. Under the tab Pricing Models, the service provider can create a pricing model to suit each service. The parameters here are price, billing cycle, included service calls, and the contract term. After all settings have been made, the service can be activated and booked by all customers via the marketplace. When the customer enters the platform, he receives an overview of his contracts and orders. He can also enter the marketplace to search for new services. If a service is purchased, this is first and foremost an inquiry to the service provider, as the actual processing of the contract must take place in the traditional way. After the service provider has authorized a request, the customer receives access to all relevant data on the service, such as the API key or the necessary data format. With this information, it is possible for the customer to automatically use the service. In doing so, the platform not only secures the communication, but also uses the stored pricing model to only allow the permitted number of calls. For more information on the project, please visit our project website. Scan the QR code at the top right. If you would like to contact the project management directly, scan the QR code at the bottom left.